Okay, welcome back. I wanted to do a lesson on logarithms this week because when I was in high school, maybe I didn't pay enough attention, but logarithms were pretty confusing to me. So I'm just going to go over some of the basics and show you some examples. So logarithms are used to help you find exponents. It's just written if you have a base number to some power, you get some answer, or you can call it b to the p equals a. So for your notation, let's say you had 3 to the x equals 9, and you want to know what x equals. Then you write it as log base 3 of 9 equals x. So you have log to some base of the power equals the answer. One quick note to make is that if you have, let's say log of 7 equals x, there's no base at the bottom of the log, so that means it's base 10 automatically. So you'd have 10 to the x equals 7. So 10 would be your base. There's a few different rules about logarithms that you need to learn. So the first is the power rule, where inside the logarithm you have an exponent. So let's say you had log of 2 to the 1/2. You can actually pull the 1/2 out and put it in front of the logarithm. So that would equal 1/2 times log 2. And if you had, let's say, log x cubed, then that would just be 3 times log x. For the quotient rule, if you have a fraction inside the logarithm, you can actually split it into 2 different logarithms. So with log 12 over x, that's just equal to log 12 minus log x. And then for the product rule, where you have a product inside the logarithm, let's say log 8x, you can also make 2 logarithms where you have log 8 plus log x. And these are useful because you can go back and forth. If you have a problem with multiple logarithms, you can combine them into one, or go the other way around and split a big logarithm up. So putting it all together, if we had log of 7x squared over 2, I'm just going to use the quotient rule first. So that equals log of 7x squared minus the log of 2. And then we can split that first logarithm up into log of 7 plus log of x squared minus log 2. And then that gives log 7 plus 2 times log x minus log 2. One thing you'll run into in chemistry or physics mostly is the natural log. And that's where the base, instead of being 10 or 2 or whatever, it is Euler's number, which is e, which is approximately 2.72. So Euler's number just comes from an infinite series. We start with n equals 0 to infinity of 1 over n factorial. So if you write it out, you just have 1 over 0 factorial, which is 1, plus 1 over 1 factorial, which is 1, 1 over 2 factorial, which is 1/2, plus 1 over 3 factorial, which is 1/6, and the n just keeps going up to infinity. And when you add all that together in the sum, you get approximately 2.72. And this can also be written in limit form. Limit of n going to infinity of 1 plus 1 over n, all to the n power, will equal e. So it's a constant number that Euler discovered, and it's used a lot. Here are some fundamental examples. Let's say you have the log of 1. That's going to give you 0, because you have log base 10 to some power equals 1. And you can change the base however you want. The only power that'll give you 1 no matter the base is going to be 0. If you have a 0 in your logarithm, then that's going to be undefined, because there's no power that gives you 0. For the natural log of x, I'm just going to rewrite it so you can see what it looks like. It's equivalent to log base e of x. And then for the natural log of 1, that's also 0, because that's the same as saying e to the 0 equals 1. Okay, I have a trickier example here. I'm going to go through it a few ways, just to give you a feel for how these rules work. So log 5 equals log of x squared. To isolate for x, you can actually take each side to the power of 10, because the base of the log is 10. So 10 to the log of 5 equals 10 to the log of x squared. And that gets rid of the logarithm. So you have 5 equals x squared. And then if you take the square root of each side, you're just left with x equals plus or minus the square root of 5. Another way you could do this is take the 2 out of the exponent of the right side. So you have log of 5 equals 2 times log x. And then you can divide the 2 over to the other side. So you have 1/2 log of 5 equals log of x. And then because you have a factor outside of the log, you can put it inside as an exponent. So you have log of 5 to the 1/2, which is also the square root of 5, equals log x. And then do each side to the 10 to the power of each side. So you have 10 to the log of 5/2 equals 10 to the log of x. And that gets rid of the logarithms. So you have 5 to the 1/2 equals x. So x is just plus or minus square root of 5. For this example with natural logs, you can just do e to the power of each side. So you have e to the ln of x cubed equals e to the ln of y. And you're just left with x cubed equals y. And if you solve for x, x is just the cube root of y. For this example, we're just going to simplify. So because you have a minus sign in the exponent, you have a term subtracting another. And you can split it up into 2 terms. So you have e to the ln of 4, and that's multiplied by e to the minus 2 ln of 2. Because remember, when you multiply terms with exponents, you add the exponents together if the bases are the same. So that's going to give e to the ln of 4 times e. And you can take the minus 2 and put it inside the logarithm. So you have e to the ln of 2 to the minus 2. And now that you have all the terms inside the logarithms, you can use the base of e to get rid of the natural logs. So you're left with 4 times 2 to the minus 2. And that just equals 4 times 1 over 2 squared, which is 4 times 1 over 4, which is just 4 over 4, gives you 1. For this last example, we're just going to use our rules to simplify the statement. Now, I like to use the quotient rule first. So we're going to have ln of x squared times y minus ln of 7 plus ln of 7 minus ln of x. The ln's of 7 go away, subtract out. And you can break this term up, so you have ln of x squared plus ln of y minus ln of x. And then here we can use the power rule, so you have 2 ln of x plus ln of y minus ln of x. And then we have 2 ln of x minus ln of x, so that's just ln x plus ln y. And I suppose you could rewrite this as ln of xy. Another way you could have done this, because we have a plus here, you can actually combine the terms. I just wanted you to see how logarithms work. So if we combine the terms from the logarithms, which use the product rule, so you have ln of x squared y over 7 times 7 over x, ln of x times ln of y, because the 7's divide out, and then one of the x's divides out the x squared.